Hi guys. So the other day we were learning about vertex form. You guys learned how to identify the vertex, the axis of symmetry from an equation written in this new form called vertex form. Today we're going to learn how to go back and forth, converting from one form to another. So if you look at example 2 from your notes that we started the other day, it's asking you to convert the given equation into standard form. So remember standard form, you're looking at y equals ax squared plus bx plus c. So if you look at the given equation and you think about how can I get it to look like y equals ax squared plus bx plus c, it's really just a bunch of rearranging of things. You've got a binomial being squared. That's got to get squared. You have a -2 on the outside that has to get distributed in afterwards. And you have a -6 at the end that has to get combined in there. So that's all we're going to do. We're going to take f of x, we're going to take f of x equals -2, and I'm going to multiply x minus 5 times x minus 5 because the binomial is being squared, and subtract 6 at the end. Now you could distribute the 2 in first if you want. It'll go into the first set of parentheses only, remember, but I'm going to FOIL first. This gives me x squared minus 10x plus 25. And then I'll distribute the -2, and then I'll subtract the 6. Any order is fine. So I have -2x squared minus 20x minus 25, and then minus the 6. So in standard form, y equals -2x squared minus 20x. Oh, sorry. Calculation error. This is -50 minus 56. And that's my equation. Same formula, same equation, same function, but now written in standard form. All right, now the harder conversion is the other way around, from standard form into vertex form. And the Regents typically asks you to do it by this method of completing the square. So they'll say complete the square to write the function in vertex form. So even if you could find another way of doing it in vertex form, my questions are going to model what they do, which is use the method of completing the square. Really similar to what we did completing the square to find the roots. Only in those situations you had, instead of equal to y, you had this equal to 0. So this is going to be slightly different because now you have a y. This is for the function. This is not to find the roots. This is not to find where y equals 0. So our first step is going to be very similar, which is to get the c value over to the other side. So I'm going to subtract 3 on both sides. And I have now, I'm just rearranging things. I have y minus 3 equals x squared minus 4x. I'm going to follow the same second step, which is to complete the square, which means you're going to take half of b and square it. So I'm going to take half of -4, and I'm going to square it, which is going to give me -2 squared is 4. That gets added to both sides. So I'm going to add 4 to both sides of my equation. I now have y plus 1 equals x squared minus 4x plus 4. Again, you end up with a similar situation where this is a perfect square trinomial. Always, that's the point of completing the square. So I'm going to rewrite it as a binomial squared. I'm going to rewrite it as x minus 2 squared. Again, I haven't changed anything. I'm just moving things around and rewriting them. And your final step is to isolate y. So this is where you have a little bit of a different step than when you're finding the roots, because we're trying to just write the function. Y equals, and then you just write it. Now it's in vertex form, x minus 2 squared minus 1. So the idea is that somebody can look at this and see, oh, the vertex is, and then it's positive 2, negative 1, just by looking at it. Okay, and this is now the same function written in vertex form. Now, it gets a little more complicated when your a value is not 1. So the next example, actually the next example is the same for you to try on your own. A is 1. So why don't you guys pause the video and then try this one on your own. Okay, I'm going to do it now. So I'm going to, remember f of x is y. So if you just leave it as f of x, or if you want to switch to y, that's fine. But I'm going to move the c value over to the other side first. I now have y minus 32, or f of x minus 32 equals x squared plus 12x. I'm going to complete the square. I'm going to take half of 12, which is 6, and square it. That's 36. That gets added to both sides. I have to keep that f of x there. Y, or f of x, and then I have plus 4 equals x squared plus 12x plus 36. Again, this is now a perfect square trinomial. I'm going to rewrite it as a binomial squared, so that's going to be x plus 6 squared equals f of x plus 4. And all I have to do now is isolate y. So now I'm in vertex form. F of x equals x plus 6 squared minus 4. And again, looking at this, you could see that the vertex would be -6 comma -4. The a value is out here. It's an invisible 1. Okay? And again, it gets a little more complicated, a little more tricky when a is greater than 1. So, or not equal to 1. So let's look at those. This is where a is, actually I should just say not greater than, but I should say a not equal to 1, because it technically could be a fraction or a -1. So what we're going to do is we're going to start out the same way. We're going to move our c value over to the other side. So I'm going to have y minus 5 equals 2x squared minus 4x. And here's the new step. If a is not equal to 1, which it's not here, that number is going to get pulled out as a GCF. Okay? Pull out 2 as a GCF, even though it's not actually the GCF. The GCF would be 2x, but I'm not pulling out the 2x. I'm only pulling out that 2. So I am now going to rewrite this as y minus 5 equals 2 times x squared minus 2x. Now here comes the tricky part. Well, not yet. I'm going to complete the square. So I'm going to take half of b. B is in here. B is this value here. I'm going to take half of b and square it. So that's going to be -1 squared is 1. I'm going to add 1, but I'm going to add it in the parentheses on the right side. So I'm going to do this. X squared minus 2x plus 1. But on the left side, I'm not going to add 1. I'm putting a box. Because really I didn't add 1. That 1 is inside of parentheses and it's being multiplied on the outside by a 2. So in reality, I multiplied the right side by 2, because 2 times 1 is 2. So whatever this multiplies to equal, that's what you're going to add on the left side to make them balanced. That's the tricky part. So if I rewrite this now, I have y minus 3 equals 2 times, and the binomial squared is x minus 1 squared. Now you can isolate y, add the 3, and you have y equals 2 times x minus 1 squared plus 3. So you're in vertex form, and you can see your a value here is a number that's greater than 1. A is 2, or not equal to 1. A is 2. So that tells me that the parabola is narrower than y equals x squared. And again, I could see the vertex, which is 1, 3. Okay, we'll try another one. My a value here is, you could see, is -3. So I'm going to go through. If you want to pause the video, you can pause it and try it, or you can just watch. I'm going to move the c value over to the other side. I'm going to add 27. I have f of x plus 27 equals -3x squared plus 24x. I'm going to pull out this number, the -3, as my GCF. -3 times x squared minus 8x. Even though, again, it's not fully the GCF, we just want to pull out the a value. And I'm copying everything else. I'm now going to complete the square. I'm going to take half of -8 squared, which is going to be 16, and add 16. When I add it, I'm adding it in the parentheses. But its true value is not really 16 because it's being multiplied by -3. So on the left side, I'm putting a box again. I'm not adding 16. It's times -3. It's actually subtracting. It's really -48. Okay, so I'm going to subtract 48 on the left side to make them, again, balanced on both sides of the equation. So I now have f of x equals 27 minus 48 is going to be, what is that? 21. So not equals, hold on. F of x minus 21 equals, and then I'm going to write this as a binomial squared, x minus 4 squared. Now all I have to do is move this 21 over, and I've isolated y. Your goal is to isolate y. F of x equals -3 times x minus 4 squared plus 21. And there you are in vertex form.